I'm going to go over the groups within the real number system, and throughout this quarter in the Trans Math 2 class we'll be referring to these types of groups. And so this is just an introduction in what those groups are and what they include and what they don't include. Anyway, all of you should have a copy of this worksheet. I'll be passing them out in class. If you don't have this and you're watching this at home, you can go ahead and just take some notes. So the first innermost group is called the natural numbers group, or they're also referred to as counting numbers. And so I'll write that in here, counting numbers. And they include numbers that start with 1 and move up. So 1, 2, 3, and so on. Okay. Notice they do not include 0 or any negative numbers. They do not include fractions or decimals. They're just numbers that when you were a young child you learned to count and you started with the number 1. The next group up that includes the natural numbers are called whole numbers. Now the only difference between whole numbers and natural numbers is that it includes the 0. So 0 would be your first number, and then you would have 1, 2, 3, and so on. So I'll go ahead and write it as 0 and then those other numbers and so on. Now the next group up is going to be called integers. Integers include negative numbers as well as the whole numbers. Notice the whole numbers have 0 and positive numbers. Integers will also include negative numbers plus the 0 and the positive numbers. And I'll go ahead and now it doesn't have to be, it's going to include to infinity on both negative and positive. So I'm going to represent this with a number line, and it's going on in both directions. And so we'll start with -2, -1, 0, 1, 2, and so on. So it's going in both directions. Also to take note is that the integers do not include fractions or decimals. Again, they're just whole numbers, counting numbers, and the negative of those numbers, but they do not include decimals or fractions. Moving up, we have rational numbers. Rational numbers or basically a rational number is any number that can be expressed as a quotient or a fraction. And it could be a repeating or terminating number. So let's get some examples here. So if we have, say, 1/4, this is a terminating fraction. It's in simplified form. I could represent 1/4 as a decimal number. Okay. Also, we have repeating, 1/3. This can be represented as 0.3333 and so on. Or you might have a number like 2/3, and we might represent it as 0.6 with a line above it. Okay, that represents that is a repeating or a recurring decimal number. It's going to keep going, and it's going to follow this pattern. It's just going to repeat the 6s. So we can have fractions or decimals, terminating or repeating. And we can also have positive and negative. So we might have something like negative 1.0625 or 1 and 625 10,000ths. Or excuse me, negative 1 and 625 10,000ths. Anyway, these are some examples of rational numbers, and we'll be working with those as well during this quarter. The next group that doesn't include these, but is part of the real number system, is called the irrational numbers. Now, ir means not. So basically, they're not rational numbers, okay? Meaning these are numbers that cannot be simplified as a terminating or repeating fraction or decimal, okay? And some examples are pi, okay? And pi in decimal form is a rounded number. Here's one, 3.14 is often used in place of pi. Another irrational number is the square root of 2. 1.414 is often used for the square root of 2. However, this number, both of these numbers, keep going, and they'll go on forever. But there is no repeating pattern. It's just a different combination of numbers as it goes. Okay. Now there are other irrational numbers. 1/7 is an irrational number. Or excuse me, not 1/7. The square root of 3 is an irrational number. And that is 1.732 and so on. Anyway, these different groups are part of the real number system. Outside of this system, if you continue to take math, there'll be the complex system, and I'll just write that behind or below. We're not going to talk about complex numbers in this course, but if you continue to take math, you will certainly learn about them. If you have questions or need more examples, ask in class.